aggregate a fixed set of data members into a single object. In C++, struct is expanded to include function members. That usage will be covered in the Classes and Objects chapter. In this movie, we'll only be dealing with the standard C struct. Let's go ahead and open struct.cpp. I'm going to make a working copy of that and paste it into our working project. Scroll down and double-click to open it. Let's go ahead and expand that to the full screen so we can take a look at the entire file. Here we have a struct, and we've named this struct employee, and it has 3 data members. It has an int, and it has 2 character pointers. And then down here in main, we say struct employee, and we give the variable a name. So this creates a variable of the type struct employee. And we initialize that with this initializer list. And it has these 3 members, 42, Joe, and boss. And so that's the employee ID and the name and the role. All right, let's go ahead and compile and run this, and then we'll take a look at some details. So there we have it. It runs, and this string prints out. Joe is the boss and has ID number 42. First thing I'd like to point out here is the use of the keyword struct here in the declaration. In C, this is required. In C++, and you'll often see it this way, you can actually eliminate that, and this will still compile and run. If I was compiling this with a C compiler, that would not work. We would need that struct keyword there as well. And so I'll leave that in for now. And it doesn't hurt. In my personal usage, I tend to use the struct keyword, and it's part of my making a distinction between struct and class. In C++, this is actually a fully first-class object. You can have function members here as well as data members. In C, it doesn't work that way. You can't have the function members because C doesn't have the object-oriented extensions that C++ has. And really the only distinction between struct and class in C++ is that the data members default to being public in structures so that they work just like C structures, and in a class they default to being private. So I tend to use struct in places where I mean just an aggregate of data, and I tend to use it exactly like a C struct, and it works perfectly. And if I really intend to have function members, then I go all the way and I create a class with private data members and public function members, and I use the class keyword instead to really make that distinction that this is a data structure and not a class with function members. So inside of the struct, you can really have any valid type. I've got 2 different types here. I've got character pointers and I've got an integer. And when you access it with this dot notation. And so joe.name refers to the name field inside of the employee structure in the variable named Joe. And .role refers to the role field, and .id refers to the ID field. If instead I was accessing this via a pointer, and so let me create a struct employee pointer, and I'll go ahead and I'll assign that to the address of Joe. And so now I have this pointer instead, and I can do this, EP, and use that notation there. And let me just go ahead and duplicate that across here, and we'll compile that and run it and see that that works exactly the same. We get exactly the same result. And this is a very common idiom. Now I have a pointer that points to this type, and I could have several of these struct employees, and I could simply assign this pointer in a loop or however it is that I want to do that, and then I can access them directly. So this pointer dereference operator, or structure dereference operator, or class dereference operator, however you want to look at it, that dereferences a pointer and accesses a field, all in one operator. And so that's the dash followed by a right angle bracket, and that's the dereference operator. Now in C, and again, this works the same way in C++, but it's more commonly used in C. If you mean to be declaring a lot of these struct employees and you don't want to have to type that whole thing each time, you can do this. You can say typedef struct employee, and here you can name the type, and you can call it employee type, or you can even call it employee, and that works just fine. And so then here, instead of struct employee like that, I can say employee type, and I can do the same thing here. And again, that will work exactly as expected. And so this is a way, if you're not using C++ and you want to get around that limitation of not having to type the word struct every time. I'm not a big fan of type defs in general. There are times when they're really convenient and handy and you want to use them, but most of the time using them in a circumstance like this, it simply creates more confusion than is necessary. But that capability is there if you want to use it. So the ability to create data structures using struct is a fundamental tool in C. And as we'll learn later, it's also the basis of classes and objects in C++. So let's go ahead and delete our working file. And we'll run